Hello guys, so in this video I want to touch base with the const keyword um, in two scenarios. When the function is a const, so you have a function, right? And then you have the keyword const, and then you have the body of the function. Well, this is the return type. And the other scenario would be you have the return type, you have the function, but inside the function, let's say these parameters here are non-const inside here, but here is denoted with const. And in this scenario, let's say we have some const parameter in here, but we don't have anything here, so it's a non-const function, but we are feeding in const parameter. So those are the two scenarios we are looking at here. What difference it makes. Now, when the function has the keyword const, let's say this is scenario 1, scenario 2. In scenario 1 here, this const is ensuring that the member variables here, this cannot change within the function, right? If you try to change, let's say this guy, initial example ex here, this value is 5, you want to make it 10 in here, you will have a compilation error. But you can change it in this function here. That's one scenario. Now, although this function has, scenario 1 has a keyword const here, if you have two params, int num1 and num2, and you pass in to modify variables here, right? You can change, you're passing in a and b as a two, num1 and num2. You can change them to different values and print that out. Although you have the const keyword here, right? But the const keyword is really referring to the const keyword that precedes the that is after the function parentheses here, right? This, or it precedes the body of the function, is linked to the member variables gonna maintain their constness, right? So let's go this over again. This const here is linked to ensuring that this member variable, sorry, it's here, right, remains a const. If you have multiple member variables, it means within this function you can't change them. They'll maintain their constness, whatever was their value. That is for this const here. However, this is the const for the function, so this is a const function. In this case, this is a non-const function, but it can have const input params. So, for example, here I have int a and int b, but what if I had const int a and const int b? So let's run this code so you can see what I'm saying now, right? So here we have the code, right? We have the code here. So right now, this member variable here is just a private member variable, and I denote this function as a const. Now I can change this member variable here. Its initial value is 5. So if I run this here now, so let's do a make, and then we're gonna do a main, sorry. So you can see inside the function, a becomes 20 and b becomes 30. They are passing here with 10 and 15, but they can change, although the const keyword is in line 8 here. Outside the function, right, the num1 is 10, num2 is 15, and the um the initial value right here was 5. So why I did not see that here? Oh, it's here. Initial object value is 5, right? Now, what if I try to change this member variable in this function? Let's say I try to uncomment this. Let's see what happens. So I'm gonna save this, and I'm gonna try to run this again. So let's do a make clean, and then let's do a make. Here you go. You see, it's telling me now that member var equal 10, right? There's an error here. You cannot do this because this function is a in member function void example in const for it's saying error assignment of member memvar is read only object. Whatever they're saying there, it boils down to there's a compilation error that you cannot, because this here is a const, right? This function is a const. You cannot modify member variable of the class. So you have to uncomment this again and save this, and maybe do a make clean, and then run a make, and we run the function, and all is good now. So that explains the const before the body of the function. It deals with the member variables of the class. You can't change that, but you're able to change other input parameters that were non-const. Now, what if we take out the const here, right? So outside the const function. So now I want to do this here, guys. Let's do this. Control C. And say outside the non-const function, right? And then comment this line out. And what else we can do here? Let us make this here const, and this here int const, and take out this const here. Now, the mere fact that we can take out that const, this part should be good, but this here gonna give me errors. Now let's not change it first. Let's just comment out these two here. All right. No, let's do A was 10, so let's make A remain 10 and B 15. Right? So let's save this, save, and clean up this code. So do a make clean and clear, run make. So so just as I try to run the make here, I cannot modify these two values A and B in this function. You see, I try to set it to 10. 10 is its value, but I'm trying to modify it. I cannot do that in here. So if I comment these two out, right, but I just print them, So let's see what happens now. So let me save this, save here now. Make clean, make and main. So in this case, initial object value is 10. So the initial object value is not 10 here now. It's just my it changed. Actually, this value changed from 5 to 10. But just ignore that initial word here. I should just put object value, right? Let's do this to get rid of any confusion. So clear all of this, run a make clean, rerun a make, and then rerun the function. All right, so object value is 10. Now initially the object, the member variable here, member var, the value is 5, but in the function here I changed member var to 10. It didn't cause a problem. It's within the class. It didn't cause a problem. But I cannot change the const value, const A and B, right? I can only actually print them because I'm passing them to the function here, right? Yeah. So what is this saying is that when there is no const here, when there is no const keyword here, right, you can change the member variables of a class. So this deals with the member variables of the class. These here can be independent input parameters that are not in the class. They are input parameters, and if you change the values here, if you want to make them const, well, you'll retain them to be constants here, like their values would remain const here. Now you can have one more scenario. What if you have one member variable here is non-const? If you had a next member variable which had, like, let's say const int mem var 2. Now if you make the function const, it will make both memvar and const int memvar constant. But what if the function is non-const? Then when you pass it into this function here, you can have int memvar as non-const and const int memvar as const. So you'll retain the constness of this here, but you can change this one here. So those are the scenarios that when you're dealing with the const as an input parameter and the const as a const function. So this is what I want to share in this video, guys. So I'll stop here for now. Bye.